All right, so let's do a EOC review for systems of linear inequalities and equalities. And let's say that I have two functions. I have one, we'll call it function blue. It's a blue line and it's a function of x, meaning that when I put in x, I get a y value, and it is defined as having a slope of -1, right? So this is y equals mx plus b, remember, y equals mx plus b. These are both in slope-intercept forms, right? So y equals mx plus b, so this is going to be -1x plus, we'll do like 3, I guess. Okay, so this means that this has a 1-to-1 change in x, so every time x goes up by 1, y changes by 1, but in the negative direction. A little fuzzy here. Clear that up. Okay, right, so that's that one. We'll show what that looks like in a second. And then my green function, which is a function of x, it equals y. So when I plug in x, I'll get a y, and it is like 2x minus 3. All right, so this one, I'll just show you. Okay, so if I have a x and a y, right, this is going to start at +3. 1, 2, 3. We'll say that's 3. And for every 1 change in x, it goes down 1. So it looks something like this. That's close enough. Make my point bigger. Okay, so there's my function b. All right, so my function green starts at -3. That's that y-intercept. -3. 1, 2, 3. And for every 1 over, it goes 2 up. So 1, 2, it's like right here. So this one looks something like this, I guess. That's pretty good. And that's function green. This one has a y-intercept, meaning the x is 0 at 1, or no, that's 3. It's supposed to be 3 at 3. And this one has a y-intercept at 0, -3. Now, if you notice something about these two lines, they meet at one and exactly 1 point because they are lines on a plane and they are not parallel. So, what is that point? Well, I know that they share an x and a y value at that point. So these two lines share that x and y value, and this is already rearranged for y equals something. So this y equals that y at that point, and that's the solution for the system of equations, is the point at which these two meet. So how do I figure this out? Well, I know that the blue y equals the green y. Okay, and I'm just going to go ahead and set -x plus 3, which is my blue y, equal to 2x minus 3, which is my green y, because these are equivalent. Right? This y equals that y, so this which is equal to y must equal that, which is equal to y. That's the transitive property. Okay, so now all I got to do from here is variables left, constants right. Let's move this variable over here, right? So it's going to be, it was 2, so now it's going to be -2x. And then let's move this constant over to here. So it's going to become -3. So this is going to be combine them, make it red, -3x equals -6. Okay, so from here I just divide both sides by the coefficient of my variable term. So x equals 2. All right, so this x value I now know is 2. All right, so this is the x value where these two meet for the blue line and the green line. So if I put in 2 for x, make that 2, negative 2 plus 3 equals 1. Right, so this y value is 1. And if I do it on this one, you can see it works the same way. I can go put the 2 in, or put the 2 in right there. So 2 minus 3, 2 times 2 is 4, minus 3, that equals 1. Right, so I checked it. Right, so that works. Okay, so that point is 2 and 1. And that's how systems of equations work. If it's not in slope-intercept form, you can rearrange it to slope-intercept form. If it's pretty simple, there's another way to check it, and I'll show you another method for this later. Okay, but what if this was an inequality? What if I changed this to this, and I changed this to this, greater than or equal to? I use the equal to sign. Well, let's make this one not equal. Let's make this one not an equal to. This is just a greater than sign. Well, that changes because this is a straight line underneath my inequality. I have to keep my blue line a straight line. If it's not a straight line, it has to turn into a dotted line like that. Okay, so now it's a dotted line. Now, you can just kind of try to figure out, the y value's got to be above this line because y is greater than this, right? Or y's got to be above this because y is greater than this, right? Or you can do the origin check for the blue line. The origin check is where I take 0 and I put it in for y and x and see if it is true. If it is true, the origin is in the shaded region for blue. So let's check it. Right? So 0 is greater than or equal to 0 plus 3. 0 is not greater than or equal to, that's false. So it's got to be, my blue region has got to be right here. Okay? Now if I do it for the green one is, if I put a 0 in for that, and I do 0, that becomes 0 minus 3 is 0 less than negative, or sorry, that's negative 3. Oh yeah, that's negative 3. Is 0 less than negative 3, excuse me, greater than negative 3? Yes, 0 is greater than negative 3. So it has to be in this region because that passed the test. So where do these two regions overlap? Well, they overlap right there. Okay? So that is the system of equations of inequalities way to do it. Okay? The easiest way I've done that to make it not confusing is do the origin check. Okay? Does the origin belong in the shaded region or does it not belong in the shaded region? Okay, so that is that one. Now let me find an example for elimination. All right, so say I have two different linear equations here. These are in standard form. So I could take time and rearrange these into slope-intercept form and then do this, but it might end up with some really complicated, sloppy fraction math, and it's going to take a lot of time to rearrange those both. And the more work you do, the higher probability you're going to make a mathematical error and have a mistake. So when you have two like this, all right, that are in standard form, you may want to think about using elimination method. This is you might want to think about using the elimination method. Right? The thing about standard form, it doesn't really tell me anything about the function, but it does allow me to compare the variables very easily. Okay, and our goal here is to do some stuff to the equations, or one or both, like multiply them one or both, so that we can get the same value of a coefficient of one of the variables, and then but opposite. Right? So what do I mean by that? Well, so here I look at my 4. This 4x is 4 times bigger than that x, and this 3y is 3 times bigger than that y. All right, so I'm going to make this entire. I'm going to unsimplify this equation, or unreduce this equation, so that this has a 3, but it's negative. So let me make it 3 first. So I'm going to multiply this by 3. That makes it 12x plus 3y minus 21. Okay, but that I can't do anything with these yet. X plus 3y equals 12. So these are now the same. They need to be the same coefficient, but opposite. So I need to make it opposite by multiplying it by -1. Everything by -1. So it's going to be negative 12x minus 3y equals positive 21. Okay, so now I have this one. I'm going to bring it back down over here. Right, it's x plus 3y equals 12. So now I am able to add these two together, because when I add two functions together, I get the point at which I get one of the points at which they intersect. Right, so here I have the opposite but same coefficient. So those cancel each other out. That's 0y. Right, so I have 0y. I'm not even going to write it. They're just gone. Okay, now I have negative 12x plus 1x becomes 11x, and then 12 or 21 plus 12 equals 33. So I just divide both sides by 11, the coefficient of my variable term, and I know that x, therefore x equals 11 in both of these circumstances. Okay, so I'm gonna take no, and x doesn't equal 11, x equals 3. What am I doing? And this should be negative 21. This should be negative 21, negative 11. Divided by negative 11, and this is going to be negative 3. I almost made a couple of mistakes there. All right, so my x value is now negative 3. All right, so I'm going to pick one of these to drop that negative 3 into. I'm going to do this one because it's easier. Negative 3, right? So now I just got to solve for y. Right, I'm going to bring the negative 3 to the other side, so I'm going to get 3y equals 15, because 12 plus 3 is 15. Divide both sides by the coefficient of my variable term, and that's going to be equal to y equals 5. Right, so this is my x, this is my y. The point at which they intersect is negative 3 and 5. Okay, so hopefully that helps you with elimination and inequalities and substitution, also graphing them to figure out where they intersect at. If you have any questions, please let me know.